Hi everyone, and welcome to this video going over all of our methods for finding missing sides and angles of triangles and when to use them. So this is our last video of the chapter. You now know lots of methods to find missing sides and angles of triangles, but you might not know when to use a method at a given time. So what we are going to do is we are going to review all of our methods and go over best scenarios to use them. So let's start with right triangles. Our methods to find missing sides and angles of a right triangle are the Pythagorean theorem, SOHCAHTOA, regular and inverse, our 45-45-90 pattern, and our 30-60-90 pattern. So let's go through each method and talk about when we would use each one. Remember, Pythagorean theorem is a squared plus b squared equals c squared, where our c value is always our hypotenuse. And notice how I always use lowercase letters for sides. In the Pythagorean theorem, we only talk about sides. So if you're ever asked to find an angle, you would never use Pythagorean theorem. It's a sides-only method. And notice how there's 3 slots, A, B, and C. In order to find a missing side, you have to have 2 out of the 3 slots filled. So we would use Pythagorean theorem if we know 2 sides, and we need to find the other side. So Pythagorean theorem is good when you know 2 sides of a right triangle and you're trying to find the third side. I also want you to make a note that Pythagorean theorem is good when your answer has to be in simplest radical form. Because whenever you solve a Pythagorean theorem problem, you always end the problem by taking the square root of both sides, because if you notice we have a squared plus b squared equals c squared, and so in order to get rid of a squared, we always square root. And once you square root, you're in the perfect place to simplify your radical so that you can leave your answer in simplest radical form. So the big idea for Pythagorean theorem is that it's sides only. If you know 2 sides, you can find the third side. Now let's talk about SOHCAHTOA. SOHCAHTOA helps us remember our ratios. So the sine of an angle equals O over H, opposite over hypotenuse. Cosine of an angle equals A over H, which is adjacent over hypotenuse. And the tangent of an angle equals O over A, opposite over adjacent. So pay attention to how the ratios are lowercase letters. So those are all sides. And next to sine, cosine, and tangent is a capital letter, and that's where the angle goes. SOHCAHTOA is always used in our calculator. So you can use SOHCAHTOA whenever the problem says round, because plugging in sine, cosine, or tangent into your calculator will always give you a decimal. So you would not use SOHCAHTOA if the problem asked for simplest radical form, because a decimal is not simplest radical form. And let's think about our slots for a SOHCAHTOA problem. We have 2 sides and an angle. So we would use SOHCAHTOA if we know 1 side and 1 angle, and we're trying to find the other side. Or if we know 2 sides and we're trying to find the angle, and that's when we would use inverse. And so those are our cases of using SOHCAHTOA. We know 1 side and 1 angle, and we're trying to find the other side, or we know 2 sides and we're trying to find a missing angle, and in that case we would use inverse. And also make sure that the problem is okay with a decimal answer. Next, we have our 45-45-90 triangle. And remember, our pattern is that because we have 2 45-degree angles, 2 of our sides are going to match. So our legs will have the same length. And then we find the hypotenuse by taking whatever the length of the leg is and multiplying by a radical 2. So hopefully this is common sense, but we can only use this for a 45-45-90 triangle. Because if it's not a 45-45-90 triangle, then it doesn't follow this pattern. This is also a sides-only problem, because we would never use this to find the missing angles, because we already know that the angles are 45 degrees, and 90 degrees. So we would only ever use this to find missing sides. And this is also a good problem for simplest radical form, because with our pattern, we're just multiplying by radical 2, and by showing our work on our paper, it prevents us from having to plug anything into our calculator. So this is a good simplest radical form problem. And the same is true for a 30, 60, 90 triangle. Our pattern is across from the 30 is our x. Then whatever's across from 30, we multiply by another radical 3 to get the 60 side. And then we multiply x by 2 to get our hypotenuse. So we can only use this for a 30, 60, 90 triangle. Once again, this is sides only because we already know the angles are 30, 60, and 90 degrees. And this is also good for simplest radical form. So if our triangle is a right triangle, we will use one of these methods: Pythagorean theorem, SOHCAHTOA, or special right triangles. But if our triangle is not a right triangle, then our options are the law of sines or the law of cosines. These are our only two non-right triangle methods. The law of sines is sine of angle A over side A is equal to sine of B over little b, which is equal to sine of C over little c. And remember, we label our letters across from their big letters. So if I have a non-right triangle, ABC, little a is across from big A, little b is across from big B, and little c is across from big C. We use the law of sines when we have an angle and opposite side pair. So if we have a letter that has both its angle and its side, its big letter and its little letter, then we have a complete ratio and we are set up to use the law of sines. So we need that angle and opposite side pair in order to have a complete ratio so that we can set up our proportion using the law of sines. We use the law of cosines when we know all three sides of a triangle and are trying to find an angle. And you can think of this like SSS because all three sides will be filled in. Or we use law of cosines when we know two sides and an angle right in the middle. And that can remind us of SAS. And so those are our methods for solving a non-right triangle. Law of sines we use when we have a complete angle and opposite side pair, and law of cosines we use when we see an SSS or an SAS. So we are going to practice determining which method to use. So for these four triangles, we're not actually solving anything. We're just going to assess the information that's given to us and what we're trying to find and what method would be appropriate in that case. So starting with A, I have a right triangle. I know two sides, and I'm trying to find the third side. So nothing about angles and all about sides, which tells me that this is going to be Pythagorean theorem. Pythagorean theorem is for right triangles when you know two sides and you're trying to find the third side. And I also don't know if this triangle is 30, 60, 90 or 45, 45, 90, and so Pythagorean theorem is my only option. Let's look at triangle B. I have a right triangle, but I'm trying to find an angle. So because I'm trying to find an angle, that eliminates Pythagorean theorem. And we also don't know any other angles. So I can't use 45, 45, 90 or 30, 60, 90 because I don't know if this triangle satisfies that pattern. And so this triangle would be SOHCAHTOA. And in particular, we would probably use inverse SOHCAHTOA because we're trying to find an angle. Let's look at C. In C, I have a right triangle, and because I know one of the angles is 45 degrees, I already know that the other angle is also going to be 45 degrees. And so because this is a 45, 45, 90 triangle, I could use my 45, 45, 90 pattern. Or you could also use SOHCAHTOA if the problem said they were okay with the decimal answer. Since we're not sure, you can use either SOHCAHTOA or the 45, 45, 90 pattern, but just know that if they ask for simplest radical form, you probably want to use your 45, 45, 90 pattern. And our last one, the triangle in D is not a right triangle, and so that limits our options to law of cosines or law of sines. If I label my A, B, and C, and little a, little b, little c, I see that I don't have a complete pair. A is missing its angle, B is missing a side, and C is missing an angle. So I don't have a completed angle and opposite side pair, which tells me I have to use law of cosines. You can also see that I have two sides filled in and an angle in the middle, which looks like SAS, and so this is definitely going to be law of cosines. So at this point, you probably feel comfortable with a lot of these methods. If I told you to use Pythagorean theorem, or to do SOHCAHTOA, or to do the law of sines, you could. But what we really need to practice is if I give you a triangle with no other instructions, how do you determine which method to use? And so hopefully we can continue to practice that critical thinking step so that no matter what triangle I give you, you know exactly what to do in a given situation. Please let me know if you have any questions, and I will see you in class.